Now I'm taking some previous year's IIT questions. I'm starting with this question. The number of integer values of m for which the x coordinate of the point of intersection of the lines 3x plus 4y equal to 9 and y is equal to mx plus 1 is also an integer is r. And your options are, the first option is 2, the second option is 0, the third option is 4, and the fourth option is 1. This is the question from IIT 2001. We will find out the point of intersection of these two lines, and the x coordinate of these two lines should be equal to an integer. We will use this condition only. So first of all, we'll solve, since here given lines are, one is plus 4y is equal to 9. This is the first line. And the second line is y is equal to mx plus 1. This is the second line. Now you have to solve these two equations, because the condition with the x coordinate, so we will just find the x coordinate. See, from the second equation we will put y in the first. So I'm writing here solving 1 and 2. It becomes 3x plus 4 into mx plus 1 is equal to 9. And by solving this, we will find the value of x. So it comes to equal to 5 upon 3 plus 4m. And according to the question, this 5 upon 3 plus 4m should be an integer. The numerator is 5, which is a prime number. So to get this result is an integer, we need this 3 plus 4m should be a divisor of 5, and according to the question you can see the number of integer values of m means m is also an integer. So this 3 plus 4m should be an integer, because the 5 is a prime number which is an integer, 3 plus 4m an integer, as well as 5 upon 3 plus 4m, everything is an integer. So which is possible only when 3 plus 4m is a divisor of 5. That is 3 plus 4m is equal to either plus minus 1 or plus minus 5. Now by solving these two, we will find the value of m. If it is an integer, then it's okay. So when you consider 3 plus 4m is equal to plus minus 1, taking this, we will find out m is equal to plus minus 1 minus 3 divided by 4. It will be either minus 2 upon 4 or minus 4 upon 4. Minus 2 upon 4 is minus half. Minus 4 upon 4 is minus 1. So you will get the two values of m in which the 1 is not an integer, so we just cancel out. And this minus 1 is an integer, so we will take this m is equal to minus 1 when we take 3 plus 4m is equal to minus 1. Now we will consider taking 3 plus 4m is equal to plus minus 5. So from here m is equal to plus minus 5 minus 3 upon 4. Here also you can see when you take the positive sign, so it will be plus 5 minus 3, that is 1 upon 2. And when you take the minus sign, it will be minus 5 minus 3 upon 4, which is minus 2. Here also you can see this half is not an integer, so we just cross, and here we will get an integer. So m is equal to minus 2 and m is equal to minus 1 will give you two integral values of x, and hence the option number first is the correct option, that it is the value of m will be 2, for which the x coordinate of the point of intersection of these two lines is also an integer. I am taking another question from again IIT. The question is, a straight line through the origin O meets two parallel lines 4x plus 2y equal to 9 and 2x plus y plus 6 is equal to 0 at points P and Q respectively. Then the point O divides the segment PQ in the ratio. And your options are, the first option is 1:2, second option is 3 is to 4. Third option is 2 is to 1. And the fourth option is 4 is to 3. And this question asked in IIT 2002. First of all, I am drawing the figure. See, you have two parallel lines. One is this and one is this. Suppose this is the line, the first line, which is 4x plus 2y is equal to 9. This is the second line, which is 2x plus y plus 6 is equal to 0. You can see here the c minus 9 and this c is plus 6. Whenever you have c with the opposite sign, always remember the origin will lie in between these two lines. The origin should lie here, anywhere but in between these two. This is suppose origin whose coordinate is 0, 0. Now, according to the question, a straight line through the origin meets two parallel lines. So, you can draw any line through this origin. Any line you can draw. Suppose I am drawing this line which intersect the first line at P according to the question and the second line at point Q. And then you have to find out this ratio OP is to OQ. What we will do here, you did in the geometry similar triangle. We will use that property here. See, because of these two first line and second line are parallel, so I am drawing a perpendicular through O. Suppose this perpendicular through O intersect the first line at M and it intersect the second line at N. Now you can see this triangle and this triangle are similar. So ratio of OP and OQ is equal to the ratio of OM and ON. That is, since triangle OMP is similar to triangle ONQ. So we can say OM upon ON is equal to OP upon OQ. It means to get the result OP upon OQ, we will find out OM upon ON. OM is the distance of the line from the origin and ON is the distance of the second line from the origin. So now we'll calculate OM and ON. So now we will consider OM equal to minus 9 upon root under 4 square plus 2 square, which is equal to 9 upon root 20, which is 2 root 5. It is OM. Now we will calculate ON. So ON is equal to mod 6 upon, because here the 2x plus 5 plus 6. So 6 upon root under 2 square plus 1 square, which is 6 upon root 5. So OM upon ON is equal to, it is 9 upon 2 root 5 divided by 6 upon root 5. So it is 9 upon 12, 3 upon 4. So OP is to OQ, which is same as OM is to ON, which is equal to 3 is to 4. And hence, according to the question, the 3 is to 4, that is the second option is the correct answer.